Oh, we actually have 3 of those things. We were doing it yesterday using this one, but I'm going to use the smaller ones. Okay, so the next one is exercise 2 on page 7. So measuring density with food. And the reason this is a demonstration is because we really just don't have the materials around to have you guys do it. And probably there'd be breakage, and especially the corn syrup is really disgusting, and so it's best that I do it. So the first part of the direction is add 100 mLs to a tall something or other, and so we'll put that aside as well. So we're just looking at this one. Of water. So the water is right here. And since there's already gradations on there, I don't need to use these guys to add it. So 100 mLs here, I'll even turn it. So it goes to that line there. Now what I found yesterday, ooh, I probably already have screwed it up. What I found yesterday is that adding food color to, or food coloring to, which is the next step, 3 drops of food color, to the water, really, it's kind of difficult to get the mix. So I'm now going to try various means of attempting to get that mix. Try not to. There we go. That was pretty successful. Okay, the next step is to add 100 mLs of corn syrup. This is the disgusting part. It's not high fructose corn syrup, it's just corn syrup. You take the starch, making sure I'm going to the right one. That's 150, that's 100, so I'm going to there. You take the starch that's in corn and you purify it. You know when I'm getting near 200. I think that's it. Yeah?
Yeah.
Yeah, see, it's already a mess. So you take the starch that's in corn and then you treat it with an enzyme that breaks down the starch, cuts it up into basically glucose molecules. If you have high fructose corn syrup, the next step is you take the glucose and use another enzyme to convert it to the sugar fructose. And the utility there is that fructose has, it tastes sweeter to us than glucose does, but it also turns out that our bodies utilize fructose in different ways. Turn that off, or blanket. Our bodies use fructose in different ways from glucose, and glucose doesn't hurt the body nearly as much as fructose does. So high fructose corn syrup is total crap. And I've actually got a video on YouTube where I talk about this. And the reason why we have high fructose corn syrup is because in the 1970s, there were sugar, this is table sugar producers, sucrose producers in Florida who were losing out to foreign producers of sugar like Cuba. So we imposed tariffs on, oh yeah, we're going to hear a lot about tariffs in a couple of weeks. Imposed tariffs on the sugar in that was being imported into the United States in order to prop up the sugar producers in Florida. But that had the effect of making table sugar more expensive. And so the companies that had been utilizing table sugar, sucrose, switched to a cheaper alternative, which was corn syrup, and they made the corn syrup even cheaper by making it sweeter by turning it into high fructose corn syrup, which turns out to be terrible for our bodies. And as a consequence, we now have, because of these tariffs, we now have expensive sugar, or more expensive sugar, and we also have people dying of all sorts of heart disease. Woohoo! Highly successful. The other thing I'd like to talk about there is that back in the 70s, in response to this, I used to be able to buy, I had my allowance was 50 cents for basically a week. And I was able to buy 10 candy bars, because candy bars were only 5 cents a piece, believe it or not. What are they, like $2 now? And
More like 4.
and so anyway, they doubled the price of candy bars from 5 cents to 10 cents. And I was like, that's it, I'm out of this. And I stopped buying candy. It was a long time ago. But anyway, this is not high fructose corn syrup, it's just regular ordinary. This is glucose, basically, a lot of glucose in a liquid form. Okay, so we're supposed to wait on that, and then we've got the other one. So to a different graduated cylinder, add 91% rubbing alcohol. So we're actually supposed to be adding wine in this rather than rubbing alcohol, but I decided that we really can't bring wine into here for us, especially since we need to have the wine to be alcoholic. Last semester, I got talked into, which turned out to be a real mistake, getting non-alcoholic beer for the fermentation lab. And it was just terrible. so I'm not even touching that. We're working with isopropyl alcohol here. And it's supposed to add to that 100 mLs of vegetable oil. Let's see if I can do this without dropping the container. That's kind of emulsified, but it's not going to stay that way. Part of the issue is that to some degree, the vegetable oil is actually going to dissolve in this 91% alcohol, but it is going to separate, I hope. So you can see on the bottom here, in fact you can see on the bottom here, that's the corn syrup. And you can see on the bottom here, that's the oil. And the reason why it's a cloudy color up here is because you've got the alcohol on top, and the alcohol is actually partially dissolving the fats, and that's an emulsification process. But we're supposed to wait, but we can turn this one because it's separated already. So it says wait 3 to 5 minutes for the layers to separate. The liquid with the highest density will be on the bottom, and the liquid with the lower density will be on the top. So what this is telling us is that this corn syrup has a higher density. It's essentially heavier per unit volume than the liquid is, than the water is. So now, okay. So in these handouts and these exercises, I will have things that are in italics, lines that are in italics, and that is a question for you to answer. And when we are either handing in these things or you're taking a quiz over them, those questions are legitimate things that can be asked of you in the quizzes. So that's what that is. And so that's saying, and this is an observation, right? We're looking at it, we're seeing what's happened. So we could have predicted which would be on top. We probably have to do Google searches to do that. Yeah. And not only that, well, first of all, no. But in the quiz is going to be multiple choice, and so it doesn't even matter. You just need to have an answer. I mean, it's obviously the idea is good. So I put in front of here that this is an observation, right? So which layer is on top? Is it the water or the corn syrup? So this is the one here. Of course, we put the food coloring in the water. And you can see how that's kind of clearing down there. So that's the first question that we're asking. Ooh, that's working out really well. So then on page 8, we have another question. And so this is an interpretation question, not an observation. So knowing that the water is on top and the corn syrup is underneath it, which of the two is more dense, water or corn syrup?
Water.
That's right, corn syrup. We know that because it's essentially heavier per unit volume. So then we've got our second observation, and this is really working out well. Which layer is on top, the alcohol or the vegetable oil? So the vegetable oil is yellow. Oh, yeah, that, can you see the distinction? Actually, maybe you see it better that. So, yeah, so which is on the bottom here? What's our observation?
On the
Yeah.
bottom?
Vegetable oil.
Vegetable oil, that's right. So which layer is on top? It would be alcohol. So then we've got an interpretation here, so therefore which layer is more dense?
Vegetable oil.
Vegetable oil. Very good. So again, those are not hard things to do, but we've got, I mean, we might have attempted to predict this, but now we've done the experiment and we've got an observation, and we know what density means, that if something's more dense, it should be on the bottom. And therefore, the interpretation of this is that vegetable oil is more dense than the alcohol, which is actually interesting because if you mix oil and water, of course, the oil is on top and the water is underneath, and therefore the oil is less dense than water, but apparently it's more dense than a 91% alcohol. I don't know how it would have worked if we used one. So now we've got a real experiment here. So it says, this is our predictions. We're actually going to do a prediction. So of chocolate chips here, which I can't eat because they have milk in them. I'm always looking at ingredients. Sugar, chocolate liqueur, cocoa butter, butterfat, which is a milk product, soy lecithin. Well, actually, I mean, technically, this really doesn't contain necessarily lactose. In fact, another way you can tell is how much sugar. Well, I guess there's already sugar in here, so you can't tell with this. If you've got something like a cheese or something, it tells you how much sugar is in the cheese. If it says 0, then there's not going to be any lactose in there. Or not much. And going further with that, apparently mozzarella cheese is really low in lactose, so that's something I consume quite often. Now that I have to make up for, what was that?
Mozzarella?
Mozzarella, yeah. You wouldn't believe that, right? I wouldn't have believed that.
Yeah, I'm lactose intolerant too, and for some reason,
You can't do mozzarella?
mozzarella's spotty. Like others are like more consistent if they give me problems or not, but mozzarella just.
So how do you do with cheddar?
With cheddar?
Yeah.
Nightmare.
You're-
I mean,
you're-
I've gone
you're-
back into
you're-
tolerance with it.
Yeah.
Somehow I've trained myself to be fine, but like.
Well, so when you train yourself vis-a-vis lactose intolerant, it probably means somehow you've modified the gut bacteria. This is another aside. So with lactose intolerance, what's happening is that you can't digest the lactose because you can't break the bond between the glucose and the galactose that makes up lactose. Those are monosaccharides. Lactose is a disaccharide, which means it goes right through you. And when it goes right through you, two things are going to happen. The first is that you get osmotic diarrhea because there's going to be a lot of a solute in your large intestine, and instead of your large intestine drawing water out of the feces that it's making, instead water is going to be drawn into it and you get diarrhea. And the second thing is that the bacteria in your large intestine are going to be able to digest the lactose, and when they digest the lactose, they're going to digest it using fermentation, and that's going to, in many cases with fermentation, release gas, like CO2 and what have you. And so you get all bloated and you get diarrhea, and it's horrifying. That's interesting that I wonder what's going on with the different.
Yeah, I don't know. Like I eat dairy for like a couple of weeks. I just thug whatever problems it causes me out,
And then suddenly.
and then just suddenly
You're
fine. But if I
probably-
stop for a week, suddenly it's all bad. I don't know the signs of it.
Yeah, no, it's going to have something to do, I bet, with the microorganisms, the bacteria that live in the gut.
Probably.
Yeah. Anyway, and that makes things really complicated. But in any case, back to this. So we're going to ask a prediction. So we start dropping the chocolate or the marshmallows or the ice. These are just ice cubes. What's our prediction about basically where these things are going to show up? So they could float on top. They can go to the dividing line between the two, or they can go to the bottom. So what I put together is a table, and these are for predictions. So Basically, with the water and corn syrup, you expect the chocolate chips to float on top, go to the dividing line between the two, or sink to the bottom. And then we can ask the same question with ice, and then we can ask the same question with marshmallows. So these are predictions as to what's going to happen. And then you have the alcohol with the vegetable oil, and we're asking the same thing. Will the chocolate chips drop down to the bottom? Will they stay between the two layers, or will they go to the top? So it all depends on the density of the things we're dropping in. And density is of course, what this lab exercise is all about. And so then the same thing with ice. Is it going to be on top? Is it going to be in the middle? Or is it going to be bottom? Of course, with water, ice floats. And we have explanations for why that is, but I won't go into it today. And then with marshmallows, are they going to float? Are they going to be in the center? Or are they going to be at the bottom? Okay? So everybody put down their predictions. This is your sense, your intuitive sense in this case, of what is going to happen. Because we can then do the experiment. So I'm going to start out the experiment with the chocolate chips. If only because I like to list things in alphabetical order. I've taken way too many out of here, but we can start dropping them in.
Oh.
This is called a technical repeat. We're repeating it over and over again, and we're getting the same result. So those are the chocolate chips into the alcohol and oil mixture. Can you see what's there? Okay, so now we're going to put it into the water and the corn syrup.
Is that the line?
Yeah, that's pretty well you can see actually, because we put in 100 mLs of each. I'll put in a few more.
Wait, is it on the dividing line?
Yeah, sorry. Yeah. For those of you at home, it's right here, right at the dividing line. So actually, this I didn't put in here, but does that mean that the corn syrup is more dense or less dense than the oil? Yeah. You actually did an experiment. Okay. Marshmallows. So, is the marshmallow going to float on the alcohol, or is it going to sink? I'm seeing nodding. I'll just drop 3 of them in. Obviously, it's going to float, right? And is it going to float on water? I mean, so that's easy. So we're still in the middle there. We're at the bottom there. Okay, now the big one is ice. So ice, of course, floats on water. Is it going to float on the alcohol? Is it going to float on the oil? What do we think? What's our prediction?
Float on the oil.
Other people? Anybody else? Float in there. Okay. Are we ready? Hopefully you can actually see this. I'm going to drop it in.
Where's the line?
Yeah, it's floating on the water. That's alcohol. Sorry, it's floating on the. Oh, wait! What's going on here?
It looks
Whoa!
like the marshmallow down.
Whoa! Oh, it banged the marshmallow down? No, what's happening? So first of all, it went on top of the olive oil, but apparently it's cooling off the alcohol and causing the alcohol to drop down. That's so cool. So yeah, I mean, your prediction that it would be floating on the oil seems to be correct, but apparently more things are going on here than that. I love doing experiments. I'm kind of a data junkie. Okay, is the ice going to float on top of the water? I guess it's probably obvious. Or is it going to be at the dividing line, or is it going to be at the bottom?
Is it nice?
No. So when a pond freezes over, what freezes first, the top or the bottom? These days we don't have winters anymore, so who knows, right?
Oh no, maybe
Yeah, no, ice, well, okay, what do we expect this ice to do?
Then it's flat.
We expect it to float. The reason why ice floats, so it's right there. The reason why ice floats is because ice has a molecular structure, actually an intermolecular structure, that creates larger voids than the voids that are found in liquid water. So for the same number of molecules, it's taking up a larger volume. And as a consequence, it is less dense. And therefore, ice floats on water. It's a good thing, because otherwise, bodies of water would freeze from the bottom up, and then they'd never unfreeze, and we'd all be dead. So this is an important, we'd never actually exist. This is an important aspect of water's properties. So anyway, so our observations are, so this is the water and the corn syrup. And so our observations are, we've got the marshmallows on top, we've got the ice on top, and we've got the chocolate chips in the middle. So those are observations. And then over here, we've got the marshmallows on top, we've got the chocolate chips on the bottom, and then we had seen somewhere in the middle that the ice is somewhere in terms of its density between that of the oil and the alcohol. So which is denser, water or alcohol? 91% alcohol.
Water.
Yeah, and that's because?
Ice sinks in alcohol and floats on water.
Yeah, yeah, exactly. So we had a prediction, we had an observation. And to some extent, I'm sure our prediction and observations coincide, and to some extent they don't. So one of the tricks to being a good scientist is knowing enough body of information so that your predictions actually make sense. In fact, this is something that Richard Feynman was talking about, that lay people, they can come up with their predictions, their hypotheses all the time, they're kind of meaningless because they're doing it more or less, they're coming up with these ideas more or less within a vacuum. Whereas once you have more knowledge, when you start making predictions and hypotheses, they're more meaningful. They actually are things that have a greater potential to be correct. Okay, are we done with this?